for number 16, we have another one of these problems that has multiple parts, so let's just go through each one individually. So statement 1 says, if the sequence a sub n is convergent, then the series a sub n is convergent. Okay, so that's a pretty easy one to bring up a counterexample. This is clearly false. Here's how you could do that. What if you had the sequence of all ones? You just have 1, 1, 1, 1, 1. That's clearly a convergent sequence. It converges to 1. However, the series definitely does not converge because you just keep adding 1. That would never come to a convergent sum. So this is definitely false. So statement 2. If a sequence is divergent, then its series is divergent. So this is the opposite statement of the one above. And this one is going to be true. So anytime your sequence of numbers does not get to a particular value, then your series diverges. And this is basically the test for divergence. Remember that for a series to converge, the limit has to be 0, and even then sometimes series don't converge. So if a sequence diverges, right away you could say that its limit is not 0, and if its limit is not 0, its sum is automatically going to diverge. So number 2 is true. Alright, statement 3 says, if you have two series that are divergent, so we have a sub n and b sub n, which are divergent, then the sum of a sub n plus b sub n is divergent. The series of the two sequences added together. Again, this one, it just suffices to come up with a counterexample. This one is going to be false. And here's the one way you can do that. Similarly to how we did number 1. Let's say a sub n is a sequence of all ones, and b sub n is a sequence of all negative ones. Those are both clearly divergent series, because you're just adding 1 and adding negative 1 that doesn't converge to a sum. However, if you add them together at each stage, you always get 0, and the sum of a sequence of all zeros is definitely 0, and that converges. So that's one counterexample. So this statement is false. Finally, number 4. So now we have something slightly different. So we have if a sub n is convergent and b sub n is divergent, then the sum is divergent. I believe this one was an exercise in your homework at some point, but this one is definitely true. So if you have a convergent series and a divergent series and you add them together, you're always going to end up with a divergent series. So the only way that you could make a divergent series convergent is to add another divergent series to it. You can think of it like this. Since this series right here is divergent, when you add this convergent series to it, as you go deeper and deeper into the series, this is like adding 0 because it converges. We know that it converges. So you're basically not doing anything to alter the divergence of that series. So 4 is true. So we have only numbers 2 and 4, which is answer choice A.